Okay, so I'm going to do a quick run through of our T4B absolute values, and I'm going to break it up into a couple different parts. So we're going to start with graphing. Alright, so when you have the graph of absolute values in a line, or really any type of graph, any number of times that two graphs or lines intersect are solutions to that system. So in this case, we have 2 points of intersection, and so our number of solutions would be 2. Okay, for this one, these two graphs do not intersect at all, so that would be a no solution. Next one, again, you have 2 points of intersection, which means that there are 2 solutions. And then in this case, you just have the vertex of your absolute value and a line intersecting, and that is 1 solution. So you have a possibility of 1, 2, or no intersection points for these types of graphs. All right, absolute value is a distance. Okay, it's always the number of units from 0 to that number, or the distance from that number to 0. So absolute value is always going to be a positive number. When we are graphing absolute values and their solutions, we are graphing into 2 separate parts and then look for their points of intersection. So when you're graphing an absolute value of x, we're thinking back to those transformations that we did in 3a. In this case, we are not going left or right at all. We're not going up or down at all. So our vertex is at 0, 0. And then for absolute value, it's just a line, y equals x, but in both directions. Okay, so you go up 1 over 1 on both sides. So that's our absolute value of x graph. And then to graph 5, you just do a horizontal line through 5. And in this case, you can see we have our 2 intersection points. We are going to write them as 5 and negative 5, not as a point, because in this case, you don't have a y in your equation, it's just an x. So we're just going to write down what the x values are. Okay, for our next one, we notice that we have this negative out in front. And we know that from our transformations, that means that our graph is going to be reflected over the x-axis. So it doesn't move left or right. It doesn't move up or down. Our vertex is at 0, 0 here. And because it's going to be reflected over the x-axis, our points are going to go down and over so that our graph is flipped. So that's our negative absolute value of x. And then the graph for negative 3 is just a horizontal line through negative 3. Once again, we have 2 solutions, and they are x equals 3 and negative. Okay, now we start to add in some more transformations. This minus 3 means that your graph is moving to the right 3, but not up or down at all. So we have our vertex at 3, 0. There's nothing in front, which means our graph is still just going to go up 1 over 1. It's just that it's going to do it from a different vertex. So that's our absolute value graph. Once again, our graph for 5 is just a horizontal line through 5. And in this case, you just have to extend your graph 1 more point to make it fit. Okay, so we have our 2 solutions. In this case, we have x equals negative 2 and x equals 1, 2, 3, 4, 5, 6, 7. Nope, 8. Sorry. Okay. All right, next one. Again, we're looking at this number in here as our horizontal shift. So in this case, we're moving our vertex to the left 4. There's still no up and down, so it's just going to be negative 4, 0. Remember, you're always doing the opposite on the inside. So even though it's plus 4, you're going left. And in this case, we do have that negative out front, so our graph is going to be reflected over the x-axis again. And make your points. There's our absolute value graph. Our other side is our horizontal line through negative 2. And our solutions, once again, we have 2 of them, are at 1, 2, 1, 2, so negative 2, 3, 4, 5, 6, negative 6. Okay. All right, now we add a few more transformations onto this one. We have a graph that goes right 1 and up 1. So over 2, up 1 is our vertex. There's nothing in front here, so I'm just going to go up 1, over 1 on both sides. And then we have a horizontal line through 5. Okay, and then we have our two solutions. So x equals -2 and x equals 6. Okay. Next one gets a little bit trickier because we do have a reflection. We have a stretch. We are not going left or right at all because there's nothing inside here. We are going up 2. So let's start with our vertex. We know that it's going to be, we're not moving left or right, but we're going up 2. So there's where we're going to start. Now in this case, because we do have a stretch and it's negative, we know that our graph is going to be reflected over the x-axis, but it's also going to get skinnier. And the way that we're going to graph it with this 3 in front is that is going to act as your slope. Okay, so if you did slope in Math 1, so that just means that it's going to go up 3 over 1. Run out of room that way. So then down 3 over 1, down 3 over 1, down 3 over 1. Yeah, this would be the same thing as saying, in this case it would be 3x plus 2. But okay, so your slope again, 3 over 1. And then the negative, it tells us that we're going in the negative direction. Okay, so we're going to do same slope on the other side, and we notice that our graph does in fact look very skinny compared to the other graphs we've done with no stretch. Okay, we're going to graph our other solution, which is -4. We still have our two solutions. So x is going to equal -2 and +4. Okay. Last two we have here, the absolute value is going to follow the same rules we were doing. And then on the other side, we do have more of a diagonal line instead of a horizontal line. So let's graph our absolute value first. This is going to tell us left 2 and down 5. There's no negative in front, so we're going to be graphing it up. There's no stretch or compression, so we're just going to go up 1 over 1 in both directions. And then for our other line, this is your y equals mx plus b. Okay, b is your y-intercept, your starting value, so we're going to start at 3. And then this -2 is your slope. So that means you go down 2, right 1. And let me just keep going. And this actually intersects. Should have one solution for this one. Oh, I didn't go down enough. Those points should have lined up better. All right, let's try this one again. Okay, our line is correct. I miscounted on our absolute value. All right, so -2, 1, 2, 3, 4. There we go. Now we see our intersection point. We have only one solution in this case, and it is x equals 2. Okay, because it happens right there. All right, last one. We have a left shift of 2, no up and down, so our vertex is going to be at -2, 0. We do have our negative out in front, so it's going to be flipped. And there is no stretch or compression in front, so it's just down 1 over 1. And then same thing for the line on the other side like we did in the last problem. This is your y equals mx plus b, so you start at -4. That's your y-intercept, and then our slope is -3 over 1. I can go down 3 over 1, then I kind of run out of room. So you can also go up 3, but left 1. And you see that's where our intersection point happens. I'm going to graph a few more here, and now we can see our line, and we can see our intersection point, x equals -1 in this case. Okay, so that is your